All right, let's do this example where we use polar coordinates, or we're dealing with polar coordinates, and we're going to fill in the coordinates that are of the points in polar coordinates. So I'm hoping that I can get people to get involved with this. Well, maybe not, but see this green circle here? This green circle for the whole time has radius equal to 1. So when I have polar coordinates, the first coordinate is r. Oh, sorry, I already started off with the wrong one. That's radius equals 3. So the gray is radius 1. Then the blue is radius 2. And then the green is radius 3. So I can just go ahead and okay, that's 3. And then the next coordinate is theta, and the theta is the angle that we make with the positive x-axis, which we actually call the polar axis. Where A is, can you tell me what that angle is? Let's do it in radians. Could throw it out in degrees. What angle do you think that is? Anybody want to speak up?
Pi over 4.
There you go, pi over 4, which is in degrees, 45 degrees. So we could write 345 degrees. So, all right, awesome. Let's now move on to B. Change up to B here. Now B is lies on that circle where the radius is 2. So that's going to be 2 for the radius. And then what is the angle theta? Let's do once in radians and the other one in degrees. Where B is, whichever you want to start off first. Should we start off with degrees or radians? What's B for the theta? Anybody want to speak up?
Is it pi?
Yes, pi, and that's 180 degrees. Now we'll move on to C. And by the way, this is not the only way we can describe these points. So probably a book will, with nicely better, a little better written and thought out, they will say, well, let's make your angle theta between 0 and 2 pi, or 0 and 360 degrees, because I could have also said pi over 4. Let's talk about A. A can be also described as, for theta, the theta could be pi over 4 plus 2 pi, or pi over 4 minus 2 pi. That'll give you the same point. So it's sort of natural just to write down the point so that theta is between 0 and 2 pi, but it doesn't have to be like that. Okay, now for C, R is in that inner circle there. That's where the radius is 1. And then theta, well, here's pi. And pi can be written as 4/4 pi, and it looks like we're adding another 1/4. So 1/4 pi plus 4/4 pi makes 5/4 pi. And that is also 1. And see, this pi is also 180 degrees. And then we add 45 degrees. I'm going to do it in my head. 180 plus 45 is 225 degrees. So you could write it like that. And all right. How about D? Anybody want to just go for it? Just give the whole answer for D? Let's see. What is R for D? It's on the green circle. What will R be?
3.
3. And then what will the angle be? And you have an infinite number of choices. But 2 come to mind of what you might want to write it as. You can throw it out in radians or degrees. What are you going to write down there? Come on. Yeah, okay, I'm going to write down, how about negative pi over 2? But some people say, no, I want to do 3/2 pi. Okay, those both would come to mind as sort of convenient numbers to write down. But I mean, you could do 3/2 pi plus another 2 pi. But those are, those are the ones that I would think are just sort of the more natural ones to write down. Okay, so well done. Let's move on to another example.